In this section, we're going to look at the intersections of quadratic and linear functions, in other words, parabolas and lines. The what we're going to learn is to use properties of both quadratic and linear functions to determine points of intersection. And the how you show me you've learned it is to actually determine if a quadratic and linear function intersect, and if they do, then to find those points of intersection. All right, first let's review a little bit about the idea of intersection. The analogy we used was like the intersection of two streets, in this case First Avenue and Second Street. And for example, if SpongeBob happens to be standing here, then he's on First Avenue and only on First Avenue. If he happens to be standing here, then he's on Second Street and only on Second Street. But if he's standing in the intersection, then he is on First Avenue and Second Street both at the same time. So the math word that we associated that with was equals. The intersection of two streets, in a sense, the two streets are equal in the intersection. And if we have two functions that are equal at some point, that's where they intersect. When we consider the intersection of a parabola, a quadratic function, and a line, a linear function, there are actually three possibilities. One, the parabola and the line never intersect. Or we could have this situation where there are two intersection points between the line and the parabola. Or the third, this situation where we have what's called a tangent line. This line just intersects this parabola at this one point. So those are the three possibilities. All right, let's go ahead and look at the procedure for actually finding the intersection of a parabola and a line. So let's take two functions, one quadratic and one linear. So f of x equals x squared minus 6x plus 11. And a linear function, simply f of x equals x plus 1. Now using the grapher, here's my parabola, x squared minus 6x plus 11. Here's my line, x plus 1. And you can see that this is one of those cases where the line and the parabola intersect in two different spots. So let's see if we can figure out what those spots are. Remember, our idea of intersection is where the two functions are equal. So I'm going to set them equal to each other. Now, we've never dealt with anything like this before, but however, we have seen what happens when we have a quadratic function equal to 0. We can use our quadratic formula, figure out what its roots are. So I'm going to rearrange this so that I have a quadratic function equal to 0, which means I'm going to have to subtract this x, subtract this 1 from both sides. So I'm going to end up with x squared minus 7x plus 10 equal to 0. Now I can put this into the quadratic formula. So let's review that just a little bit real quick. Remembering that in our quadratic function, this invisible 1 out here in front of the x squared, its coefficient is a, the negative 7 is b, the 10 is c, and our quadratic formula is minus b plus or minus square root b squared minus 4ac all over 2a. So let's simply fill in the values and see what we get. So I get minus b is 7 plus or minus square root of 7 squared minus 4 times a, which is 1, times c, which is 10. All of this divided by 2 times a, which is 2. So that's going to equal 7 plus or minus square root. Well, 4 times 1 times 10 is 40. 7 squared is 49, so that's 49 minus 40, which is simply 9 over 2. But square root of 9 is just 3. So that's 7 plus or minus 3 over 2. So 7 plus 3 is 10 over 2, which is just 5. And 7 minus 3 is 4 over 2, which is just 2. So now I have my two x values the roots of this equation we came up with, and we can figure out the y's that go with it. Now, remembering the same way we did this with lines, if I take this 5 and put it back into either of these equations, I'm going to get the y that goes with it. Well, this one's a lot easier to deal with here. So if I put 5 in for x, I'm going to have 5 plus 1 or 6. So one of my points is going to be 5, 6. If I put in the 2, it's going to be 2 plus 1. That's 3. So my other point of intersection is 2, 3. So there are my 2 points of intersection. This one here, that's 2, 3. And this one up here, that's 5, 6.